Good morning, children. Hope you had a hectic week. And now we are coming to the last week of our test series and last test for physics. Okay. So, on coming Tuesday, you will be having test of heat and energy. Okay. You will be having test of heat and energy, 25th of August. Okay. Now, as I told you before itself, lot of portion has been cut off from the syllabus. Okay, first of all, you mark that. First and second part are there. Third and fourth part are completely cut. According to the syllabus, these two are cut. And in fifth, it's given greenhouse effect and global warming, scientific definitions only. You can cut off the scope thing and it's written only scientific definitions. Okay, this is according to the syllabus wise. Now according to your book, if you see, part B and C not in syllabus, part D only definitions, only scientific definitions. Okay, so you forget about syllabus, you see according to the book. Now according to the book, part A you will study fully. Okay, so all these things you will study, and anomalous expansion, and we've solved this exercise in detail. Now B, no need to do, and C also no need to do. Now C has had a very vast thing, but everything has been cut. And coming to D part, you just have to do two definitions. So greenhouse effect and global warming. So the definition of greenhouse effect is here. Okay, it has 3 points if you remember, from here to here. And then definition of global warming is here. So it's enough if you study only these two definitions. So from D part, only these two definitions will come. Okay, so mostly A part is what you have to focus on. Okay, focus mainly on the A part. So quickly we'll do a recap of this. So first thing will be difference between heat and temperature. Then unit of heat, calorie is also a unit, but it's not the SI unit. Joule is the SI unit. So what is the relationship between calorie and joule? So 1 calorie is 4.2 joule. You need not even remember 186. So 4.2 joule, if you remember, that's fine. Okay. Now definition of heat and temperature already will be covered in the difference between. Then units of temperature, you know, we have Celsius, Fahrenheit and Kelvin. Kelvin is the SI unit. How to convert Celsius to Kelvin, that is given here. Okay, now come to the main part, that is thermal expansion. So this is the definition of thermal expansion, expansion on heating. Then you have two definitions of anomalous expansion. One is anomalous expansion of a substance, general one, and then you have anomalous expansion of water. Now, anomalous expansion of substance means expansion of substance on cooling. Now, generally on heating only it will expand, but expansion of a substance on cooling in a certain range of temperature is called anomalous expansion of that substance. Okay, but anomalous expansion of water, specifically will write expansion of water when it is cooled from 4 to 0 degrees Celsius is called anomalous expansion of water. Then we have some examples of substances that show anomalous expansion. So you need to study all these three examples. Water from 0 to 4, silver iodide from 80 to 141, silica from minus 80 to below minus 80 degree Celsius. Okay, so this is what is here, and as I told you before itself, these two graphs are very important. Anyone you can expect. So this is the volume temperature graph, and it will be like this. As I have told you already, temperatures you should write 0, 2, 4, 6, 8, 10, but in volume it's enough if you write only this value, that is 1. Okay, same way here also temperature will show. Volume you need not show all these numbers, you can show. Okay, so be careful, this is volume of 1 gram of water in centimeter cubed. You have to write it fully. volume of 1 gram of water in centimeter cubed, temperature in degree Celsius, density in gram per centimeter cubed. It's not kg per meter cubed, gram per centimeter cubed, that is 1. At 4 degree, it will be 1 gram per centimeter cubed. Okay, so these two graphs along with these explanations. In your notebooks, you have written clearly. Please read, study from the notebook. It will be very helpful. Then comes Hope's experiment, which I did not do before. Okay, but we have to do it now. Okay, so this experiment is to prove the anomalous expansion of water. Okay, so um, in this apparatus, you have a containing water. Beaker containing water. This is normal water, and then there are two holes in the sides through which two thermometers are kept. Okay, this is named as thermometer T1, this is thermometer T2, and in the middle they have kept a bowl having some ice. Freezing mixture means they'll put some salt and ice, then it won't melt. Okay, so on a trough they put some salt and put some ice and put some salt so that it doesn't melt, and it is kept fixed around this middle part. Okay, now what do you observe? If you see the observation, so this is the cylinder, this is the water, and then thermometer T2, and this is thermometer T1. This is called freezing mixture, and this is the trough. So what will happen is, now initially, okay, so this thermometer, now suppose let's take the temperature of water was 12 degrees Celsius. Okay, it was in a winter day, you fill from a tap and it was 12 degrees Celsius. So initially this will be showing 12 degrees Celsius, and this will also be showing 12 degrees Celsius. Both the thermometers will be showing 12 degrees Celsius. Okay, now once the experiment is started, this will be showing 12 only. Okay, but this thermometer, you will see the temperature quickly falling from 12, okay, 12, 11, 10, 9, it keeps coming down gradually till 4 degrees Celsius. Now what is happening here? Now because of this freezing mixture, in the middle part, okay, there is ice here, so this middle part of the water gets cooled first. Okay, the water here gets cooled first. Okay, and this is thermometer T2 and this is thermometer T1. Okay, so initially both were showing 12 degrees Celsius. This is still showing 12 degrees Celsius because the water we took is at 12 degrees Celsius, and then this was showing 12, but once the experiment started, its temperature will gradually fall. Okay, 12, 11, 10, all that, till 4 degrees Celsius. You can see a quick fall in the temperature. Now why did the temperature fall? To understand that, now because the middle part alone is surrounded by ice, this part of water first gets cooled. Okay, this part of water gets cooled, means it was initially at 12, from 12 it will come down to 11 degrees Celsius. Now when that process is happening, cooling, okay, when cooling is happening, density will increase. Density normally, okay, normally, not anomalous, not that unusual thing, normally. So water till 4 it will behave normally, only between 4 and 0 it's going to behave unusually. So from 12 till 4, the water here, as it keeps getting cooled, its density will increase. Now when density increases, it becomes heavier, and so this layer of water will sink down and the next layer of water will go up. Okay, I think you'd have heard this word called convection current. Convection means the liquid higher density will sink down and the liquid of lower density will rise up. Just keep going. Now, the next layer of water would have come up, then that would have reduced from 12 to 11. Like that, every layer would have happened. Then, again, the same phenomenon will start. Now, after 11, the temperature will come down to 10. So, till 4 degrees Celsius, from 12 degrees Celsius to 4 degrees Celsius, water behaves in a normal way. Water behaves normally. Okay, so what happens normally means cooling is happening, density will increase, and therefore it sinks to the bottom. So the temperature, this lower temperature will come till 4, and at 4 it will stop. It won't go below 4. Why is that so? It's because once it has reached 4, now 12 to 4, it behaved in a usual way, normal way. Now, below 4 or between 4 and 0, it's going to behave in a anomalous way. What is that anomalous way? That means water on cooling from 4 to 3, density will start decreasing. Usually density increases. Now density will start decreasing and it will not sink. Water will remain floating at the top. So once this all has reached 4 and now again the convection starts, and this layer from 4, when it comes to 3, it can't go down. Why? Because its density has decreased. Its convection current is not possible. So now it can form a current with respect to this one. Okay. Now earlier, with respect to this was heavy, so it was going down. Now with respect to this is lighter, and so it will start going up. So that's why thermometer T2 will stop at 4. This part of the water will remain at 4 degrees Celsius. So if I draw a graph between time and temperature T2, okay, thermometer T2, this is thermometer T2's graph I'm drawing. Initially, it will fall from 12 degrees Celsius till 4 degrees Celsius. It will fall. But after that, it will remain constant. Okay. From 12 to 4, it will show a decrease because this is happening. But below 4, because of this, no more the water can come down. Convection cannot take place. No convection possible with lower part. So, this thermometer cannot show any more fall in temperature. Okay, this is what happens with T2. Now let's see what happens with T1. Now till that time, T1 was showing 12 degree. Okay, because there was no convection formed in this part of water. This will remain at 12. Okay, and so this thermometer was showing 12. Now once this process here is over, and this all has reached 4, and this has now become 3, 4 to 3, it cannot go down, but it can go up, because when compared to water at 12 degrees Celsius, this will be now lighter, because 4 to 0 cooling density decreases. So because its density is decreased when compared to this, it can no more stay down, it will go up. This is also convection. Okay, lower density going up. So to fill this, the next layer of water would have come down, and then that would have been cooled to 4. And this will happen. So from now onwards, this thermometer will be showing a fall in temperature: 12, 11, 10, 9, 8 excuse me, 7, 6, 4. So till 4, again same thing. Till 4, it will show the same thing. Again, below 4. Okay, so once this reaches 4, now convection will happen in the upper part. So now this thermometer will start showing a fall in temperature, and it will fall till 0 degrees Celsius. it will fall till 0 degrees Celsius, because even when it is going to go below 4, like this phenomena will happen, and so till 0 it will convection is possible, and this entire part of water will reach 0 degrees Celsius. Entire part of water will reach 0 degrees Celsius. By the time it reaches 0, it is the freezing point, so this top layer will become ice. Top layer will remain frozen, as it will remain frozen, it will become ice, and the lower ones will remain at, this one at 0, this one at 4 degree Celsius, and this thermometer would have come down till 0. Now if I have to show a graph for thermometer T1, time and temperature, this would have remained at 12 degrees Celsius for a long time. Okay, then it started falling till 0 degree Celsius. It will not stop at 4, it will fall till 0 degree Celsius. So that's why you have a graph here. For T1, you will have a graph like this. For T2, like this. Okay, children, I hope you understood this, and try to read through it. You will understand the Hope's experiment. Okay, then consequences, as I told you, you know that what to study from this, and there are a lot of extra questions here I made you write in your notebook. Please go through them also. Okay, so this will be a comparatively smaller chapter, smaller portion you have to study when compared to the other chapters. So hopefully you will be able to do well. Hope's experiment, first time when you hear it seems to be confusing, please hear this twice or thrice, then you read through it, then you will understand. Is it clear? So now that's all for today. You can start preparing for your test. Okay, so they can ask the reasons, like why did it stop, it did not go below 4, why did it go till 0. So all those reasons which I explained, you should be able to write. Thank you, children.